Okay. Okay, so that's how having been said. Elvis, do you concur with what she just said?
Yes, ma'am.
Okay, Raphael, what about you?
Yes, ma'am.
Okay, so for the benefit of those that are joining us today, when it comes to first principle method, these are the things you'll be seeing. Changing y over changing x. I explained how this came about using a graph, okay? But if you pay attention with what I'm going to introduce now and say now, you'll be able to still understand. So the first thing you're going to do, when an equation is given to you, let me just do one, simple one. If you say that it should differentiate y with respect to x, and they say that y is equals to x, let's call this equation 1. But before then, can everybody differentiate y with respect to x and tell me what it is? Ordinarily, what is it? What it is, I mean.
1.
1, right? Okay, so now let's use first principle method to do that. Okay, so if you have y equals to x, the first thing you are going to do, you can be writing it down if we are not here last time, is to add change in y here and add change in x here. So you have y plus change in y equal to x plus change in x. All these things will happen anywhere you have x. You add change. If you're having more than one x here, you're adding change in x to all of them. Okay, and I believe that all of you were here when we did the algebraic identity. So if after adding change in x and change in y, the next thing you are going to do is to remove equation 1 from equation 2, because this one is equation 1 and this is equation 2. You remove equation 1 from equation 2. Tension. And that will give us x plus change in x minus x.
Ma, can you repeat the second step?
Second step is to subtract equation 1 from equation 2.
Oh, okay.
Yes. Are we there? Is everybody
Yes,
there with me now? Hello?
Yes,
Can you guys hear me?
Yes,
Okay, so we are removing equation 1 from equation 2. As you can see, y plus change in y minus y, and x plus change in x minus x. Okay, so this minus this will give us change in y equal to x minus x will give us change in x. That is the second step. The next thing you are going to do after you remove equation 1 from equation 2 is to divide both sides with x. Yes, change in x. That is the next step, the third step. So if you divide by change in x, you have change in y over change in x. And this is change in x over change in x. This cannot divide it, so it remains the same. So here cancel here, you have 1 now. If you're having 1 here now, the next step, that is almost the last step, is to limit change in x. Limit change in x to 0. Anywhere you see change in x, you call it 0. So we are limiting change in x to 0. If you limit change in x to 0, you see that change in y over 0 will give you 0. So our dy over the x, we don't have change in x here, is equal to 1. It's just like using general method. Our advice, if you have the question as simple as this, first of all, use general method to differentiate before you use first principle method to be sure that your answer is correct. First step, add change in y. Change in y here, change in x here. Second step, subtract equation 1 from equation 2. Third step, divide by change in x. Then last step, limit change in x to 0. And that's all. The y, the x, that is differentiating x with y with respect to x will give you 1. Okay? So that is that. Before I go into, because today we agreed that we'll be differentiating functions in fraction and roots and even powers. But before then, for those that missed class last time, I will give you 1 to use first principle method. We did it last week, but just to bring you people up to date. I will give you one question now to differentiate using first principle. I'm waiting for 3 of you. Is Diamond here?
No, ma'am.
Why?
Anyway,
he didn't participate very well last week. He was coming and going, and now he's not here too. Okay, but the two, Jen and Judith, they're here, and Sharon, they are here. So what I'm going to do now, I will give you a question. In 2 minutes, please use first principle method to differentiate this. In 2 minutes. So that we can go straight. I want to do correction for last assignment. Elvis, did you post the assignment on the platform? Okay. You push you differentiate.
Yes,
okay, it's okay. So I believe that some people made attempt. Even though I've marked your own. Okay, so I'm waiting. Judy, Jane, Sharon, if Diamond comes, fine. Please, I want people to differentiate using first principle. What did they get? What did they get? Yes, I can hear you. What did you get?
The 28 on the other side, this is squared.
Yes, it's squared. You know, I hope people were around when we did what is it? Right identity, because it's a okay. So let me just do something there and see if you people are in line with what we are doing. Okay. So if y is equal to this, and we call it equation 1, Elvis and Susan, are you here? Is Susan here? Raphael?
Yes, ma'am.
Okay. So I want you people to be telling me what to do here. Y equals to this. So what am I doing next? Y plus change in y equal to
X plus change in X.
good. X plus change in X squared. Okay? For those that are just joining us today, we did this thing last week. Just to bring everybody up to date. Okay, so this and this and this, we have done the second step. But remember, in algebraic identity, I told you that when you have 2 numbers, so that is addition, sum of square, okay? If you expand this now, if you have x plus change in x squared, instead of you to start doing x plus change in x plus bracket, x plus change, and start expanding, there is a rule I gave, and I want you to use the rule to tell me the answer. So what's the rule? What am I supposed to write here? No. I'm talking to Judith and Jane and Sharon.
Okay.
Yes. Yes, the last time we did algebraic identity, I told you how to expand it. So I want you to tell me the expansion. What will it be?
You were not in the class for the algebraic identity. So.
And you people didn't collect notes. You didn't collect notes from others. You didn't ask questions. Okay, Sharon, I know you normally ask questions. So please, tell me what to do there. So what am I writing, Sharon? If I expand x plus change in x, what am I going to get? Is Sharon here? I think Sharon is not here. Oh, Sharon is not here. Okay, Susan, you can go ahead.
Okay.
X square plus 2 change in x plus change in x square.
X square plus 2 change in x
Plus change in x square.
plus change in x squared. Good. So that is what these things stand for. We have to put it in expansion form so that we can subtract. Since we have put it in expansion form, we can now go ahead. Sorry, this is 2x changing x. 2x changing x. How do you do that? X square, the second step, x times changing x times 2, that is 2x changing x. Then changing x squared. That's what gave birth to this one. And that's having been said. So we subtract. If we subtract, we have y plus change in y minus y equal to x squared plus 2x change in x plus change in x squared minus y. So here can cancel here can cancel. We are going to divide this. We have 2x changing x over change x plus changing x squared over changing x. So here can cancel here. This one is 2. Oh, the hell. Okay. So if we limit it to 0, we have anywhere we see change in x, we'll call it 0. So here is 0 and mean that this one is gone. Our dy over the x will be what? 2x. If you use general method, that's still what you are going to say, because 2x plus 0 will give us 2x. Okay. So I believe that. Eh? Is it Raphael?
How do you have this one? How
Okay.
do you have higher powers like more than 2?
The thing is that if you have like 4 x raised to power 4, all that is where function of function comes in. Okay. Yes, there are some that you might not be able to use because it will have to require you expanding. Imagine you expanding x raised to power 5, meaning that that means x plus changing x raised to power 5. You see where function of a chain rule comes in. Once the power is not what general method and what first principle can do, the other methods, product rule, the quotient rule. So because we want to touch integration too, we might not go really into those quotient rule, but I might still touch it anyway. Let's write test first. But if I'm going to touch it, that means I'll have to do the quotient rule and the product rule first. Then we'll now write test next week. So it left for you guys to decide. So, but the quotient rule and the product rule, you also see it in university. So if you think we should finish all the methods before going to integration, fine. What is it? Carry it now. So that is that. Okay, so let's go straight to what we have today. We are starting with the assignment I gave. We are starting with the assignment I gave. Because I gave this as an assignment, and I know that, like Elvis owner Bank, he got it right. I will not do much here. I will wait for you people to be telling me what to write, because you people have done it as assignments. After I've done it as assignment, the reason why I will put it down is for those that the thing hooks somewhere, and I want to finish the 3 assignments. Okay, and possibly add maybe 1 or 2 other fractions and square. So the first question, if you can solve these 3 assignments I gave comfortably, that means you're okay. To me, you're okay with this first principle method. But if you cannot, try as much as possible. to solve it. And if you are not in class last week, please still collect note, because where we do x raised to power 3, that is another issue, because there is fraction of that. You know what we did with was x raised to power 3. There is fraction of 1 over x raised to power of 3. You see that there is a need for you to first of all learn that one before this one. So the first question I gave was for us to differentiate, find dy over dx, comma, if y is equal to 1 over 2x plus 1. 1 over 2x plus 1. So we call it, I'll be cleaning board, so please be writing too, because it might be long, it might not be long anyway. So our y is equal to 1 over 2x plus 1, equation 1, right? Answer me. Hello?
Yes, ma'am.
Yes, ma'am.
Okay, so what am I doing next now?
You add changing y to y and changing x.
Okay, so we add change y plus changing y equal to 1 all over. Remember there is 2 here, multiplying everything here. Okay, are we there? But we need this x out because we need to add changing x to it. So we say 2 bracket. Remember 2 is multiplying x before you add 1. So 2 will see multiplying x plus changing x, close bracket, plus 1. Is it understood?
Yes, ma'am.
Is everybody on the same? Eh? You said?
Could you start again? I can't see the board. Could you start again? I can't see the board clearly.
Okay, let me see if I can top ink. I was thinking about it, but since nobody complained and it look as if, where is that my ink? Let me check if I will see the one that is sharper. Okay, this one is it. My ink, where are you? Good, I've seen ink. Okay, just give me a few seconds. Let me. I hope Jen and Judith are here.
Yes, ma'am.
Okay. Okay.
Yes,
So,
ma'am, right?
okay, I just top in ink so that everybody will be on the same page. Okay, so I should start again. Good. We are starting again. The question says we should differentiate y with respect to x if y is this. Then we say that y is equal to 1 all over 2x plus 1. This is equation 1. Then equation 2 have y plus change in y equal to 1 all over. Remember, we are adding change in x. Anywhere we see x. Remember that this 2 is multiplying x, right? So we put 2 outside because we need to add change in x to x. And that will give us x plus change in x. We have added change in x. I remember we have plus 1 somewhere. So we add our plus 1. First step done. We have added change in y and change in x. So what we are going to add again now is, what is the next thing we are going to do actually? What is the next thing we are supposed to do?
Minus y from 21.
Minus equation 1 from...
Minus equation 1 from equation 2.
Good. So if we minus equation 1 from equation 2, please be writing the step down, okay? If we minus equation 1 from equation 2, we are going to have y plus change in y minus y, and is equal to 1 all over 2 brackets x plus change in x, close brackets, plus 1 minus 1 over 2x plus 1. I hope people still have that knowledge of addition and subtraction of algebraic fraction. If you want to subtract or add or simplify algebraic fraction when it comes to addition and subtraction, what do?
You find the LCM.
You find the LCM. Good. So if you are finding the LCM, first of all, let's finish with this side because we don't need any side that can take our time. This minus this has gone. Here in this side, we are left with change in y. Okay. There is something I think I remember. Let's first of all put our why we discussed. Let's put our LCM. So automatically our LCM be this times this, right? So we have 2 brackets x plus change in x plus 1. We close our brackets, multiply by
2x plus 1.
2x plus 1. Okay. Now there is something I remember I taught you people. I don't know if people still remember that instead of you doing this divide this times this, which is still easy, it can actually, since they are their LCM, what are you going to do? This can cancel this, it remain this. This times this will give you. You can still say this times this, you put it here. This times this, you put it this side. They are the same thing. Anyway, any method you use is okay. Let me say it again. Since this is the LCM, okay? And you can actually say this divide this. You know, when this divide this LCM, is this one that will remain, right? Are we together?
Yes, ma'am.
Good. So if you say this divide this and the remaining this will multiply 1 and have it this side. Coming to this side again, this divide this will cancel this. You remain this one, and this times this will be this side. Another way to do it is to say this times this side, and this times this side is still okay. Whichever method you follow, you are still going to get the same thing. Okay. So now I'm going to write our answer now. Okay. So here we'll have 2x plus 1 minus this side. So we have 2 brackets x plus change in x plus 1. Any question before we go ahead? Any question before we go ahead?
No, man.
No question. Okay. Now, let me make something clear so that it will not look as if we do abracadabra there. If you have minus beside the beside any bracket, I hope you know that the minus is affecting everything in that bracket.
Yes, ma'am.
Good. And what the question said, this minus this. Now let's look at it with clear eye. By the time you do 2 multiply everything in the bracket, you know that these 2 will not be 2x, right? Then there is minus here. So 2x minus 2x has gone. Then come to 1. Because there is nothing to subtract this change in x. So you still remain 2 times change in x. So it's 2 change in x that we have there. But 1 minus 1 has gone. So in that case, we don't have anything again here because here has minus here and also minus here. The only thing we are having here now is minus 2 times change in x. And that will give us minus 2 change in x all over whatever we have here. Okay? And I think is going to be okay, before I even clear the brackets, because we're definitely going to clear the brackets. But before I clear the brackets, I want us to write it the way it is first. Then you tell me how to clear the bracket. Good. So we have 2 brackets x plus change in x plus 1. Then under brackets. Bracket 2x plus 1. Is there anybody that is not following up to this point? Is there anybody that is not following up to this point? Okay, so please, I want to clear the brackets now. Even though I would prefer I divide by 4, forget ours, the other side. Remember here we'll have change in y, okay? Over change in x. Then here we'll have minus 2 change in x all over 2 brackets x plus change in x plus 1, close bracket, 2x plus 1. Here I divided with change in x and I've not done it here. And I need to do it here. Okay? Are we there? Good. So if I do it there, what am I going to get? If I do it there, what am I going to get? You know that this is like minus 2. Okay, let me put over change in x here. Let me put this over change in x here. So that here will cancel here. Okay? So automatically I will have y over change in x equals to minus 2. Are we there?
Yes, ma'am.
I don't want us to be repeating. I wanted to be for the benefit of those that might get lost if we do it from there. Okay, so that is it. We have divided with change in x. So what's the next step? Limit to 0. Okay, so anyway, we'll see limit. If you limit to 0 now, here will become 0, right? So our dy over the x will be equal to, remember that here is 0 now, right? So x plus 0 will still give us 0, right? X plus 0 will still give us 0, right? X plus 0 will give us what?
0.
Well done.
In x term.
Well done, oh. So if you're having 5 naira, they add nothing to it, it becomes nothing.
X.
So x plus 0 will give us x, right? Good. So then 2 times x will give us 2x. So automatically we'll have minus 2 all over. Here now is 2x. Remember we'll have plus 1 here. Bracket 2x plus 1. If you like, you can minimize it as 2x plus 1 squared. Yes. So our dy over the x is automatically minus 2 all over 2x plus 1 squared. That is it. So, any question on this one? Once you remember the steps and follow it judiciously, the only thing it takes is time. But whether it's simple, it's simple. Eh?
This is where you divided minus change in x by change in x.
Yes.
Why did you not cancel change in x? How will I put it?
Okay, no, it doesn't affect the denominator. It will not affect the denominator.
I know, but then cancel change in x or change in x and let's minus 2. Why did you not cancel change in x and minus 2 change in x give minus change in x?
Okay, let me understand what you're saying. You say here I cancelled minus 2 change x over change x, Abi?
Yeah, you only cancel the change in x and left minus 2.
Yes,
but
because
they're like,
yes, now because it can change in x cannot cancel 2 now. If you have minus 2 over x, will it affect minus 2?
no.
X will cancel x, minus 2 will be there.
Okay.
The reason why the change in x left here is because we have limited change in x to 0. We limited change in x to 0 here. If you say limit change in x, it means that anywhere you see change in x, call it 0. But why this one remain is because if you divide it minus 2x over x, x will cancel x. You will leave the rest now. You can only cancel the equivalent, the similar, the same letter. B cannot cancel A and A cannot cancel B.
Yes, ma'am.
Did I answer your question?
Yes, thank you.
Okay. Okay, so that's all. I hope that's the only question. So please write down. Let's go ahead to the next question. The next question. Can I clean? Can I clean?
Listen. Go for
Okay.
them, sure.
Okay. Okay. I think the next question is 1 over x. Abi? I'm using my phone to live stream. I can't check.
Yes, ma'am.
Okay. Okay, so find the derivative. The derivative of y equals to 1 over x. So you guys should tell me what to do.
Y plus change y.
Okay.
1 over x plus
Y. Okay, let me first of all write y equals to 1 over x, equation 1. Then equation 2 be y plus change in y equal to 1 over what?
1 over x
Plus change in x. Good. Okay, so the next thing is what?
You subtract equation
So
1.
Good. If you subtract y minus y has gone. Okay, no need to write it all the time. So what we have now is 1 over x plus change in x minus 1 over x.
minus 1 over x.
Okay. You can remember what we discussed earlier, ba? This times this and this times this.
LCM.
Good. The LCM will now be x plus change in x. Sharon, are you here?
X minus. Okay.
Yes,
Okay.
sir.
Okay. So this times this will give us what?
X plus change in x.
X minus. Okay.
X minus.
X plus
X plus
change
X.
in x. Are we there?
Yes, ma'am.
I'll put brackets so that people still remember that the minus is for everything in that side. Okay. So when we minus, what do we have? This minus this has gone. Abi?
Yes, sir.
The reason why I put bracket is for you to remember that everything there is for
Minus of x.
yes, math teacher. Minus is now you know. The minus is for everything there. Okay, if I did not put it, if you can just do x minus x and carry plus change the x to put there. But if you put the brackets, you still remember. So what we actually have here is now minus change in x left all over x plus change in x. Yes, bracket x. Okay.
X.
Okay, so what are we getting next? What are we doing next? Are we limiting?
No.
We are dividing.
Divide
Good.
over change in x.
Good. So if we divide now, remember I say it doesn't affect the denominator. Mhm. So if we divide, automatically we are going to have a cleaning board because I want everybody to be seeing what we are doing. So if you, by the time we'll divide through by change in x, okay, we are going to have change in y over what? Change in x equal
X
to
equal
minus
to
change in x over change in x all over x plus change in x bracket x. So what will be our numerator at the right hand side? What will be our numerator at the right hand side?
1. Minus 1.
Minus 1,
Minus 1
because here
over
cancel here, we are left with what? Minus 1. Okay,
minus 1
all over x
over
plus, yes,
plus
change in
the
x
bracket
bracket
x.
x. So what do we do next now?
Limit 0.
We limit change in x to 0. That means here now automatically is what? 0, right?
0.
Automatically
Right.
there is 0. So we have that our dy over the x. If here is 0 now, what we have is x plus 0 to give us minus 1 all over x plus 0 is x. So x times x will give us what? X squared. X squared, yes. So that is our answer. The y ds is equals to minus, you can finish it up because since down is non-negative and is positive, you can finish it up by putting your answer in a very right position. How? Dy over dx will now be equals to minus 1 over x squared, because this divide this will give you negative. So the negative, yes, that is the final way of writing it. Okay, so the last assignment, I want those that were not around to use this method to solve also. Even though Elvis have submitted his own, but I want Susan.
Yes, ma'am.
The last assignment, did you do everything?
Yes, ma'am. Yes, ma'am.
Did you see what Elvis submitted?
Yes, ma'am.
It correspond with your own?
Yes, ma'am.
Okay, all of them. Okay. Raphael, what about you? Is there anyone that you could not do, but you are picking where you made mistake now?
No, I've done it already.
Okay, you did all of them.
This one already now.
No, the first assignment that we did correction, we were able to get the correct answer.
Yeah. Yes, but I make corrections.
Okay, that is good. Okay, so the last one now, I want everybody to participate using the method, and I want people that were not here last week. Sharon is not here. Okay, is here. Please, I want people to solve that last one. Solve that last one for me, everybody. That will tell me that everybody is now okay with the formula. You're already conversant with the formula, okay? So the question says, from the first principle, find from the first principle the derivative of y equal to a plus b. Remember, a and b are constants. So you are using first principle method. Find the derivative of y equals to ax plus b.
AX
Plus b. Ax plus b. Find the derivative of y.
All of us.
No, Elvis, you have submitted yours, so it might just wait.
But I've done it already. So.
That's why I said those that were not around last time, they are the main target. Okay, they are the main target. So I want Sharon and Judith and Jen to quickly do that and tell me their answer. It shouldn't take time. It's not going to take time. Yes. True? Are they true? Thanks, guys. Thanks for your like. Elvis. Nobody's actually there, Sha. Look at it now. See the people here, 0. See number of nobody is there now. See people here, 0. So they've come and gone. Nobody wants to solve math. Nobody wants to solve maths. Why doing New Year? Everybody wants to chop chicken. If I'm gisting now, hey, you see people come. Oh, you're teaching for which one can't be changing? Why change your bag? The only change they want now, the only change people want now is to just go to bank and change their dollar to naira. Yes, sir. Yes, sir. That is the only beauty change they want. They don't want any other change in Y and change in X. When we were in university, they were teaching us ordinary differential equation. One boy just stood up. I beg, this thing, no, he said none of this thing will take somebody to heaven. The thing was actually not entering. The boy left though. You know what the boy did? The boy left, went to canteen to eat. He did not know that I think his group were fighting, so they shot him. Lecture was going on. He went to go and buy coke and eat first though, before person go die, say they learn mass. And they actually killed him. Honestly. Life no balance. One thing must kill a man. Mass no they kill. Now waiting people no know. Okay, so Judith and Jen and Sharon, I'm waiting for your answer. Can you tell me your answer now?
I got the Y the X to be A.
Okay, you got the Y the S as A. Judith and Sharon,
Yes.
Judith and Jen, what's up?
I got A. The Y over the X to be A.
Okay. You say you what?
A.
Okay, A. Okay, yes, that is the correct answer. So that is just for me to be sure before I will now give you people what you solve now. Yes. People are going to solve now one or two questions now. That is your classwork for today. That is your classwork for today. So, please. So this is your class exercise for today. Settle down and solve it without mistake. Okay. So the question say, differentiate. Class exercise. Differentiate number 1. Y equal to 3x squared. Number 2. Y equal to 1 over x raised to power of 3. Okay. For the benefit of those that were not around, when we have x plus change in x raised to power of 3, please, what is our expansions going to be? So that it will, just to help those that were not around last time. What is the expansion going to be?
x cube
X cube
plus 3x squared changing x
plus 3x squared changing x
plus 3x changing
3x
plus 3x changing x squared
changing x
changing x cube.
plus changing x cube. Good. So that when you get here, you know what to do. I've done my part. Oh yeah, you should do your classwork. Sir? Sir?
Man, you were saying like, okay, man, but is there any other way to expand this stuff without using that long method?
There's no long method. We've done it already. If you get here, is it not to change all this x raised to power 3 like this? Then subtract. Is there any other thing?
No, like, how will I put it? Like, you know how you did the okay, what if it's raised power 2 now? You just open it and expand. But this one is raised power 3. So
Yeah.
like it's more than 2 now. So you were saying that you use
Okay,
algebraic
for the
function
algebraic
of
identity. You mean for the algebraic identity? Was it not algebraic identity people used to get this one? I posted it last time on platform and I say people should expand x plus y bracket x plus y bracket x plus y, and this is what people got.
Okay.
Yes. I understand the shortcut you're talking about, but if you use it, you're going to make mistake. That one that I say x minus y bracket x square plus, is it not? Just use this one. S cube. The expansion of this x cube, x plus changing x cube. Use this one.
Okay, man.
Yes, then this one.
Mr. Moss, please explain this number to you again.
Okay, this is 1 over s cube, right? By the time you do your by the time you add changing x to x, you are going to get x plus change s cube, right?
Yeah.
This is the expansion of x plus change x cube. This is the expansion. This x plus change s cube means x plus change x bracket x plus change x bracket x plus change x. Is it not?
Yeah.
By the time you expand it, this is it. Just get conversant with, as you can see, they did not expand, but they already get conversant with it. That each time you have x plus change s cube, it's going to be s cube. Then you have 3s square changing x plus 3x changing s square plus changing x cube. Is it okay now?
Yes, ma'am.
Oh yeah, go ahead. Hi, Oma. Are we having a call live stream? Okay, you mean as I'm teaching? Thank you, Maliz. You mean as I'm teaching? Annabelle, you're disturbing me. Wait, I should leave the class and teach and start talking to people. Is that what you're saying? Okay. So let's give others like 5 minutes or 4 minutes more. Okay. Okay. So the rest, how far? How did he go? Ah. 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 Susan.
My question is not easy. It is the grace of God.
That's why I'm waiting for everybody. But the first one is supposed to be very easy now.
Yes, ma'am.
No, the second one
Semi
is
Achuku.
yeah, true.
Semi Achuku.
Is it Raphael Elvis? No, both of them can't they get the same voice. Judith Alpha, Judith and Jane. Sister Sharon.
Ma'am?
Alpha, how is the question going?
It's going as it's going.
Hey, Senova. Okay, so the first one, let's discuss the first one, right?
Yes, ma'am.
Okay. I believe everybody have done the first one now.
Yes, ma'am.
Okay. So, how did you go? What did you forget?
6x.
Okay, who else have done number one? What did you get?
6x.
Eh?
6x.
Okay.
6x.
Okay, Elvis, Alpha. Jane and Judith. Sister Sharon. Is it me? I'm not seeing Sharon here.
She has been off and on.
Okay. Okay, so what do we agree? We are writing test next time, right? Are we writing test next time? Or we should do the product rule and the quotient rule?
I'm okay with anyone you choose.
Okay. Okay, or maybe after class we'll discuss that on the chat.
Yep.
I'm waiting for that. So number one. Okay. Jane and Judith. Elvis. Okay, let me do correction for the, let's do correction for the first one. Then we continue next class because I'm already exhausted. So if y is equals to 3x squared, I think that's it. Right?
For the second, first one, yes.
So y plus change in y is 3 brackets what?
Changing. 3 bracket L plus changing X.
Are we there? Are we together?
Yes, ma'am.
Sharon,
Ma'am?
I was asking what you got in the first one.
Ma, I got 6x, but I don't know whether it's correct.
Okay. Okay, so this is it. We are doing correction for the first one. Please, let's do correction because me, I'm already exhausted. 1 plus change in y, y plus, okay, minus. This will give us change in y. No need for that one. We already passed that level, right?
Yes, ma'am.
So we have 3 brackets. If we expand, what are we getting here?
X squared plus 2x changing X plus X changing X squared.
Right? Minus 3x squared. Abby?
Yes, ma'am.
So we have 3x squared plus 6x changing x, changing x, Abby? Plus
Yes,
6
ma'am.
changing x squared minus 3x squared, so that here can cancel here, right?
Ma is 3 changing X squared, not 6. 3 is multiplying changing X squared.
Oh, yes, yes.
You
It's the
wrote
other one that is 6. Yes, yes. You're right. Is yes, is the yes, you're correct. Okay. So coming down, we have x changing x over changing y over changing x, Abby, equal to 6x changing x over changing x plus 3 changing x squared over what? Changing x, right? So that here can cancel here, and here can also cancel here. So on that note, we have we limit changing x to 0,
0, yes.
so that our dy over dx will be what? 6x. By the time you put 0 here, 3 times 0 will give you 0. So our answer is 6x. Okay. So the second question will continue next class. So if you have not finished, just go ahead, and I think I will just add one to it so that it'll be 2 questions we are solving. But before next class, so I want us to discuss that. Even if it's not on board like this, you open your assignments, we'll discuss it together. Let me see how soon. When are we meeting again? Today is what? Today is a Tuesday. Can we? Okay, we are meeting on Saturday. Okay, let's discuss that on chat, whether we are going to write test that Saturday or we go on with quotient through and product through, then write test next week, Tuesday. So I'll end this thing now, the class now. Okay. So if you are still solving the second one, go ahead and be solving, so that I don't want a situation whereby I'll just say, okay, it's okay, it's okay. Let's go ahead, and you keep on not getting it right. So get it right. Annabelle. What's going on? What is Kosi doing?